Hey, science fans, get ready for an incredible journey, one that will take us to the very fringes of our solar system. We're about to embark on an adventure to a realm of ice, mystery, and cosmic secrets. Our solar system is bigger than you think. It's a vast expanse filled with planets, asteroids, comets, and so much more, all swirling around our sun. But what lies beyond the familiar planets? Beyond Neptune, the last of the major planets, lies a mysterious frozen frontier. This is where the sun's light begins to fade and the temperatures plummet to unimaginable lows. Out here, so far from our star, the sun is just a tiny star in the sky. It provides barely enough warmth to keep things from freezing solid. This is the solar system's deep freeze, a place where the very fabric of space seems to change. It's a region of extreme cold and perpetual darkness. It's a place packed with ancient icy relics, remnants from the very beginning of our solar system. These icy bodies hold clues to the formation of planets and the evolution of our cosmic neighborhood. Imagine venturing so far that everything you know is left behind: the warmth of the sun, the familiar glow of Earth, all fading into the distance. And as you travel further, the rules of space change. The gravitational pull of the sun weakens, and the environment becomes increasingly hostile. Here, temperatures are so cold that gases turn to ice, forming beautiful yet deadly crystalline structures that float through the void. And countless small worlds orbit in darkness, each a tiny speck of ice and rock, silently circling the distant sun. These are the denizens of the outer solar system. This region isn't empty. Despite the extreme conditions, it's far from a desolate wasteland. It's alive with the leftovers from the birth of our solar system, the raw materials that never quite made it into planets. We call it the Kuiper Belt, a vast region of icy bodies that stretches far beyond Neptune's orbit. And even farther out, almost unimaginably distant, lies the Oort Cloud, a spherical shell of icy debris that surrounds the entire solar system. These regions are like time capsules, frozen in time since the earliest days of our solar system. They're preserving the story of our cosmic origins, waiting for us to unlock their secrets. They hold the key to understanding how our solar system came to be. By exploring them, by sending probes and telescopes to peer into their depths, we unlock secrets about how planets formed. And we can begin to understand what else might be out there, lurking in the darkness beyond our familiar planets. What other wonders await discovery? The Kuiper Belt and Oort Cloud, these distant and mysterious realms, are among the last great mysteries in our own backyard, a testament to the vastness and complexity of our solar system. Studying them lets us look back in time, to the very beginning of our solar system's history. We're looking at the building blocks of planets, frozen for billions of years, preserved in their original state. So grab your imaginary space helmet, because we're about to embark on a thrilling adventure. Let's journey to the edge of everything we know, to the frozen frontier where the mysteries of the solar system await. The universe is waiting, full of wonders and discoveries just waiting to be made. Let's go explore. Our journey begins far beyond the familiar planets, venturing into the outer reaches of our solar system. First stop, the Kuiper Belt. Imagine stepping out past Neptune and you'll find yourself amidst a vast collection of icy bodies. Picture a giant icy donut encircling our solar system beyond Neptune's orbit. It's a vast, cold region, a cosmic reservoir teeming with millions of icy objects. These are the Kuiper Belt objects, or KBOs, the denizens of this distant realm. These KBOs come in all shapes and sizes, ranging from tiny ice chunks, mere specks of cosmic dust, to worlds spanning over 1,000 kilometers wide, rivaling the size of some moons. The Kuiper Belt is not a small neighborhood. It stretches from about 30 to 50 times the Earth-Sun distance, making it an incredibly expansive region of space. Despite the number of objects, it's crucial to understand that this isn't a crowded asteroid field like the one between Mars and Jupiter. The space here is immense, truly vast, and KBOs are, on average, incredibly far apart from one another. Imagine sailing across an ocean, spotting only a few distant islands. Among these icy wanderers, Pluto is undoubtedly the most famous KBO, a celestial body that once held the title of planet. But Pluto is just one of many, a prominent member of this cosmic community, surrounded by countless other icy bodies, each with its own unique story to tell. These objects are not newcomers, they are leftovers, remnants from the solar system's very formation, dating back billions of years. They represent the building blocks that never quite coalesced, never quite becoming full-fledged planets. They're time capsules, frozen in time, holding the original ingredients, the pristine materials that formed our cosmic neighborhood, offering invaluable clues about the early solar system. The Kuiper Belt, with its vast expanse and countless icy inhabitants, is a massive, disc-shaped region, a flattened ring extending far beyond the orbit of Neptune. Its discovery revolutionized our understanding, changing our view of the solar system and its outer limits. Its discovery revealed that the space beyond the giant planets is not empty or static, but rather dynamic and full of surprises, a region teeming with activity and intrigue. By studying and understanding the Kuiper Belt, we can gain profound insights and helps us trace our own origins, unraveling the mysteries of how our solar system came to be. It's a treasure chest of cosmic history, a repository of ancient materials and clues about the formation of our solar system, waiting to be explored, patiently awaiting future missions that will unlock its secrets and further illuminate our understanding of the cosmos. Where did the Kuiper Belt come from? Let's rewind 4.6 billion years. Our solar system began as a spinning cloud of gas and dust, the solar nebula. The sun formed at the center, while leftover material flattened into a disk where planets took shape. Close to the sun it was too hot for ice, so rocky planets formed. Farther out, beyond the frost line, it was cold enough for ice to survive, perfect for building giant planets and icy bodies. In the region beyond Neptune, material was too spread out to form another planet. Neptune's gravity stirred things up, preventing these icy leftovers from merging into a planet. The Kuiper Belt is the debris from planet formation, a collection of untouched ancient objects. These bodies are pristine samples of the early solar system, frozen in time. They offer a direct look at the conditions that created everything, including Earth. Pluto was once our 9th planet, but it's not alone out there. As telescopes improved, we found other large Kuiper Belt worlds: Eris, Makemake, Haumea, each with unique features. Eris is even more massive than Pluto, and Haumea spins so fast it's shaped like a football. This led to the creation of the Dwarf planet category round worlds that haven't cleared their orbits. Pluto became the first of this new class, the king of the Kuiper Belt. These dwarf planets are not quite planets, not quite comets. They're a missing link in planetary evolution. Studying them reveals how planet building sometimes stalls, leaving behind fascinating worlds. Pluto and its neighbors are key to understanding our solar system's complexity. For years, the Kuiper Belt existed as a faint, unresolved blur in our telescopes. It was a theoretical realm, a distant repository of icy bodies far beyond Neptune. That is, until NASA's New Horizons mission embarked on its ambitious journey to explore this mysterious frontier. Launched in 2006, New Horizons began its long voyage. This spacecraft traveled nearly a decade, enduring the vast emptiness of space to reach its primary target, Pluto, the largest known object in the Kuiper Belt. It was a journey of incredible distance and unwavering determination. In 2015, after its epic trek, it finally flew past Pluto, forever changing our understanding of this distant world. The flyby revealed a world of stunning complexity, including vast plains of nitrogen ice, a landscape sculpted by the faint sunlight of the outer solar system, towering water ice mountains reaching heights of several kilometers, and a surprisingly complex thin blue atmosphere, hinting at ongoing processes shaping the planet's surface and environment. Pluto turned out to be geologically active, defying expectations and challenging our preconceived notions about small, icy worlds. It was not a dead ice ball, as many had assumed, but a dynamic and evolving world with a rich geological history. After its groundbreaking encounter with Pluto, New Horizons continued its journey deeper into the Kuiper Belt, eventually visiting Arrokoth. Arrokoth is a contact binary, a unique object shaped like two pancakes gently stuck together, a testament to the gentle collisions that occurred in the early solar system. Arrokoth is believed to be a pristine relic from the dawn of the solar system, a time capsule preserving the building blocks of planets. New Horizons gave us our first close-up look at two very different Kuiper Belt objects, showcasing the diversity and complexity of this distant region. The mission showed that these distant worlds are not just icy rocks, but complex and diverse planetary bodies with unique histories and characteristics. The vast amount of data collected by New Horizons is still being analyzed by scientists around the world. This ongoing analysis is offering new insights into the processes of planet formation and the evolution of our solar system. New Horizons transformed the Kuiper Belt from a theoretical concept into a real, tangible, and explored frontier, revealing its hidden wonders. It proved that even the most distant and seemingly desolate regions of our solar system are teeming with surprises and hold valuable clues to our cosmic origins. The adventure continues as we delve deeper into the data and study what new horizons discovered, unlocking the secrets of the Kuiper Belt one discovery at a time. Discovery. Beyond the Kuiper Belt lies the Oort Cloud, a gigantic spherical shell of icy objects. It starts thousands of times farther from the Sun than Earth and may stretch a quarter of the way to the nearest star. Unlike the flat Kuiper Belt, the Oort Cloud surrounds the solar system in all directions. It could contain trillions of icy bodies drifting in near-total darkness. The Oort Cloud formed when giant planets flung icy leftovers far from the Sun. Some objects escaped the solar system, but many settled into distant orbits, becoming the Oort Cloud. These bodies are only loosely held by the Sun's gravity and can be nudged by passing stars or the galaxy itself. Such nudges can send them hurtling toward the inner solar system. The Oort Cloud is the source of some of our most spectacular celestial visitors. Ever seen a comet streak across the night sky? Many come from the Oort Cloud. Long-period comets take thousands or millions of years to orbit the Sun, arriving from all directions. A tiny gravitational nudge can send an Oort Cloud object on a journey toward the Sun. As it approaches, sunlight turns its ice to gas, creating a glowing coma and tail. The Oort Cloud is the solar system's comet nursery, a vast reservoir of frozen bodies waiting for a push. Comets like Hale-Bopp are visitors from this distant realm. By tracing comet orbits, astronomers found strong evidence for the Oort Cloud's existence. Not all comets come from the Oort Cloud. Short-period comets originate in the Kuiper Belt. Our solar system has two comet sources, each revealing secrets about distant regions. Studying comets lets us sample the chemistry of the frozen frontier. They're cosmic messengers from the edge of our solar system. If the Oort Cloud is so important, why haven't we seen it? It's just too far and too dark. Its objects are tiny, spread over an immense volume, and reflect almost no sunlight. The Oort Cloud remains a theory, first proposed by Jan Oort in the 1950s after studying comet orbits. Everything we know about it comes from the behavior of comets, our best indirect evidence. Direct observation is beyond current technology, and even our farthest spacecraft, Voyager 1, won't reach the Oort Cloud for centuries. Despite the distance, the Oort Cloud elegantly explains where long-period comets come from. It marks the true boundary of our solar system, where the Sun's gravity fades into the galaxy's pull. Every long-period comet is a reminder of this invisible, colossal sphere of ice. The Oort Cloud is a beautiful mystery, proof of science's power to understand the unseen. Why study these distant, frozen places? Because they hold the keys to our origins. The Kuiper Belt and Oort Cloud preserve the building blocks of our solar system, frozen for billions of years. They help us answer big questions. How did planets form? What was the early solar system like? Exploring these frontiers pushes science and technology forward, inspiring new innovations. The drive to explore comes from human curiosity, our need to know what's beyond the next horizon. The frozen frontier is one of the last great mysteries in our neighborhood. It challenges us to keep reaching, learning, and exploring. The journey is just beginning. Imagine what we'll discover next.